Hello. We are going to start a new chapter about the hypothesis test. This chapter, so hypothesis testing is a very kind of strange and unnatural method of statistical inference. And here I'm not. So this chapter is not to introduce you the test, but I assume that you have basic knowledge about hypothesis testing. So like null hypothesis, alternative hypothesis, type 1 error, type 2 error, power, size, significance level, test statistic, p-value, critical value. You have to know them. At least you need to know them. I teach these to undergrad economic statistics courses. So if you have problem with these, you have to take. So on my YouTube channel, I think you can find my undergrad statistics course. That may help, but that's too easy. But if you don't know what it is, then it's a big problem. Like do whatever you can to understand them. And also, and you may realize the organization. The first two chapters are about the assumptions. So the identification is more about the assumptions, and in the identification argument, I kind of implicitly assume that the data is not a problem. So say we have infinite number of IID observations. And then let's think about if the model is solvable, if the model has the unique solution or not. That is the first two chapters. And the other two chapters, 3 and 4, was about estimation. Literally, the estimation is how we utilize the data, and using the data, how we can utilize the identification result. So we learned the parameter is identified, and then we have data. Then how do we connect these two? This was also another important problem. And in this chapter, so hypothesis testing chapter will have both approaches, but I will tend more toward the identification type approach, assuming that the data has no problem. The data is large, and we have sufficient data, and I don't worry too much about how we can utilize the data, because how you use the data is covered in usually introductory statistics. Right? You learned how to calculate the critical value, how to calculate the p-value, how to calculate the t statistic, f statistic. So I don't think it's new. So they will be those the data method application to data is not a big problem. There is not much difference, or quite similar to the estimation or what you learned earlier. But what I want to do here is to give you the framework, the unified framework. There is a kind of consistent framework that we are using from the very beginning of this semester. So I will continue to use the same framework, and I will give you how you can understand the hypothesis test in the same framework. That's my goal, and let's start. And the reference for this chapter is, again, Nguyen McFadden. So this paper has everything about how you use the data and how you obtain asymptotic results. And I also use textbooks like Green and Root. So utilize those textbooks. And by the way, my lecture note is my own. So it's not similar to any of them. So I combined them and I made up my own theory, unified theory. I believe it is quite a nice, beautiful theory, and there is nothing wrong. So I hope you appreciate, I understand what I did here. Anyhow, thank you. So the basic setup, I assume that you know how you implement the hypothesis test and you must have heard about some examples, basic examples. So let me go fast. So we have null hypothesis H0. This is a statement about the population. So about the mean or the probability, or like a difference between means, something like that. So and the mean and the probability there are population mean and population probability. The result of a hypothesis test is always either rejection or no rejection. It is a yes or no question. So that's the key difference from estimation. Estimation is an open question. What is the mean? What is the probability? But in hypothesis testing, you have a specific hypothesis, and your answer is, your question is a yes or no. You are asking whether my hypothesis is correct or not. And then, in the end, if the data strongly contradicts to your hypothesis, then you reject. But and if the data are consistent with your hypothesis, of course you do not reject. So these two cases are obvious decision. But the problem is there is gray area. So it is uncertain whether the data is a little bit different from the hypothesis, but not much different. How can we decide? Then our decision is favoring the null hypothesis. So if it's uncertain, you do not reject. You maintain the null hypothesis, and in many textbooks, this is called acceptance, accepting the null hypothesis. But I don't think that's correct. So instead of acceptance, I will call this non-rejection. So you are not accepting the null hypothesis. You just simply, you could not reject the null hypothesis. That is the basic philosophy of hypothesis testing. But in the end, not like, even if you say accept the null hypothesis, there is no big difference. But just to help you better understand the basic mechanism, I chose the term this way. Some examples. First example, variable selection. Here, so there are two regressors. Say all are exogenous and everything is nice, but we are interested if x2 is relevant or not. x2 should be included in this regression or not. And you may test whether beta 2 equals to 0 or not. Or you can test, it is the statistical significance testing, right? And second example, test for functional form. So you have, say, polynomial like this, and you want to test if the functional form is linear or not. Then you can test whether the quadratic, cubic, and fourth order terms have zero coefficients or not. So it is basically, these two are the same hypothesis test under different names. Or you may consider some restrictions on a combination of parameters. For example, if you think about a production function estimation, y is the output, L is labor, K is capital, and Cope-Douglas function implies log of y is a linear function of log L log K. And then you may be interested in whether the production function has constant returns or increasing returns or decreasing returns to scale. What's the scaleness, or how do we say this? Anyhow, whether if there is scale economy or diseconomy. So suppose that you believe that it is constant returns to scale, which means the parameter for labor and capital sum to 1, and alpha is the total factor productivity. So I believe, I assume that you understand what I'm saying here. If you have question, go to microeconomics professor. And then you can test whether beta plus gamma equals to 1 or not. And as you know, this is also very similar test from these guys. And quite a little bit different type of testing is inequality restriction. For example, I'm wondering whether beta x, like x1, has a more significant, like larger impact on y than x2 has. So your null hypothesis can be written as whether beta 1 is greater than beta 2 or not. And like finally, example 5, exogeneity. So this is a very interesting question. Maybe this is new example to you. So I assume that you have seen some of these guys. You must be familiar with these examples. Unless you have to have an idea how you can test them. But now exogeneity may be new. It's interesting. What we want to do here is say like regression beta x is endogenous. You have two instruments, z1 and z2. And I know that z1 is a good instrument, but z2 may not. Then we would like to test if z2 is a valid instrument. So if z2 satisfies the exclusion restriction or like the independence restriction or not. So you are testing this condition. So these are just examples of hypothesis testing. And I am going to explain a new framework to you. So I think it's good to stop the video here, and we'll start a new video to explain a more profound idea. So see you in the next video, and see you later.